Hello my dear NEET warriors, welcome aboard. I hope I'm audible and visible. Welcome to the NEET Conquer series, and today's chapter is a part of modern physics, which is basically atoms and atomic structure. And in this NEET Conquer series, we have taken up the challenge, 2 weeks challenge, if you remember correctly, of completing the entire modern physics, guaranteed 32 marks within just 2 weeks. And we are on to our next class. I hope you have watched the previous lecture, which is photons, photoelectric effect and dual nature. In case you haven't, please check out the past live videos. Nice to see you back. Hello Gokul Siam, Vidisha, welcome Priyanka, welcome Vedanjini, welcome Krishnant. I think yesterday by mistake the lecture was scheduled and I realized it in the evening, and so I had to inform the team that please shift the lecture to today, which was supposedly I don't know why was it live yesterday. Anyways, so now we are up to speed and let's begin with the lecture. And before we proceed ahead, make sure that you have smashed the like button and also subscribe to the channel, because that's your Guru Dakshina. And let me tell you, Avengers batch, which is the NEET 2024 batch, has opened up once again for all the latecomers, but at a reduced price, because there are some students who have not yet started preparation or not satisfied with the preparation of the NEET 2024. So that's why, considering the request, we have opened up 3.0. I think this should be the final entry point, because 25% of the syllabus is left. Whatever I have done, all those recordings, discussions, everything will be given to you, at that reduced discounted rate, which is less than 5,000. For that, you have to use the coupon code CAPTAIN, CAPTAIN. Go to the description box, use the link, join the Avenger 3.0 batch as soon as possible. That's the only way you will be able to enter. That is your final remedy, I would say, the last option that you have, in this particular situation, if you are not satisfied or you have, not, fully started preparing for the NEET exam. Okay, I will be teaching their physics, and you have your amazing team, Avenger team, with test series and assignments and everything else. Okay, so let's begin with the class. Thank you for liking. Kirtwatan, hello Subita, hello Ananti. Nice to see all of you. Good evening, man. Good evening, Subhashini, Nagaprakash, Ramakrishna. Nice to see all the new names, yeah. Nice to see all of you, yeah. I mean, and glad that you can make it to the live class as well. So I know next year when you crack the NEET and I see your names on the charts and on the leaderboards and on the advertisements, I know you are my student. Thank you so much. So let's begin with the lecture. And also remember, there is NEET test series available for all of you. So it includes, everything, test results, analysis, discussions. There are 16 mock tests as per the new revised syllabus, and you can get it at affordable prices as less as 3,999 for class 12th and droppers. Okay, and if you want it offline based, then you have to pay an additional fee, so that's 599 rupees. So if you want to get the real feel of the examination hall, that is. Okay, so most of you will be going for this. Some of you might want to get that real feel, so go for this particular test series. Remember that. So talking about atoms and atomic structure, what is this chapter all about? See, this chapter is all about describing how an atom looks, right? How does an atom look? People knew that you take any body, let's say, for example, I take Pandu. Even Pandu is made up of particles. If you take any part of Pandu's body, the Pandu's body is made up of particles. You keep dividing those particles into small divisions, and the smallest division that you get is an atom. So people tried to see what is that small particle which makes up the particular body look like. What does it have? What are the properties? Because that gives you the chemical properties and other properties which we usually study in physics and chemistry. So there were many theories proposed. Okay, many theories proposed. It started off with Dalton, all right, then Thomson, Thomson. Then you had basically Rutherford's model of atom. Then you also had Bohr's model of atom. And then you have basically the quantum model, the wave nature, all those things combined together. So you had the new theory, which is basically the quantum mechanics theory, okay, based out of Heisenberg and more such people. They all of them, they gave the new theory. In the NEET examination, what you have for NEET physics is mainly these things. More importantly, this one. This is the most important theory which you should study from this particular chapter. These things, mainly theoretical knowledge you should have. What is this theory? What does it say? What are the advantages? What are the pluses? What are the minuses? That's all. And you should know that Bohr's model is where we limit ourselves. But remember, there are more theories which are orbital theories, which we do not really study in detail in basically NEET physics. In chemistry you might be studying, but in physics at least you don't study. Thank you, Abarna. Thank you so much. Which Malayalam actor Rubina? I would also like to know. All right. So let's see the first model. Everybody likes watermelons. How many of you like watermelons? Thomson's model of atom is also called as the watermelon model or the cake pudding model. But cake pudding very difficult to visualize because some of you don't know what a cake pudding is. So it's okay. Simple thing I will bring, watermelon. Everybody likes watermelons, hai na? Awesome. Right now only some people are like, sir, my mouth is watering, sir. I'm feeling thirsty, sir, right now. I feel like eating watermelon. I feel like drinking sugarcane juice, hai na? So in a watermelon, you have the red part and those seeds. Neglect that shell. The red part, Thomson said, is basically where the positive charges are, or basically the red part is positively charged. And he said those seeds are like electrons which are negatively charged. In fact, Thomson was the person he discovered electron. He was the person who discovered the electron. He said the charge of the electron, and he said that the charge of the electron is negative and there is some negative particle inside the atom. We all know the charge of the electron is negative 1.6 10 to the power minus 19 coulombs. He said that the electrons are like these tiny seeds. Why did he say that? Is because he had understood the concept of how electricity moves in a conductor. Imagine if the electrons are these seeds, very easy to pluck out those seeds, tuck, and throw them away. Hai na? So in a conductor also, these electrons are like those seeds, that's what he said. And that's how these electrons get plucked out and they start moving inside the conductor, and that's how electricity flows. So that's why he said electrons are like those tiny particles which are embedded in the, a uniform, densely charged, positively charged part, which is that red color part of the watermelon. So he thought atom looks like a watermelon, uniformly charged, positively charged space is there. In that there are teeny particles, those are electrons which are negatively charged. They are freely able to move here and there, and that's how electricity can be conducted. He also said the amount of negativeness is the amount of positiveness. He also said the amount of negativeness is also the positiveness. Now this theory, though it explained few things, like what and all things it was able to explain. It was able to explain the conduction of electricity, right? It was also able to explain the neutrality of an atom. Atom is electrically neutral, meaning as much positiveness is there, that much negativeness is there. He said whatever positive charge is there totally, which is distributed everywhere, that much exactly negative charge is there in those seeds. He was able to explain those things, right? He was not able to explain many things, like why is there spectrum? Why is there atomic spectrum? What are those energy levels inside the atom? What are those energy levels in an atom? He was not able to also explain, you know, things like orbits. How are these electrons being in orbits? Because he assumed that the electrons are like stationary, which is not the case. How is the equilibrium maintained? How is it that, you know, the electrons are stationary without doing anything? Aren't they getting attracted, repelled, all those things? How is it able to, you know, sustain itself? So how these orbits are formed? He was not able to explain all these things. Hydrogen spectra, energy levels, all these things he failed. So like it happens in school, teacher asks, okay, you stand up, answer this question. That student is like 0.1, 0.2, ma'am 0.3, ma'am 0.4, ma'am 0.5, gone ma'am, sorry. Okay, next student. So we got the next student. Who is the next student? Rutherford. So Rutherford, he is the next student. He will be like, ma'am, I know this answer. I know. I can do it much better than Thomson. I can do it much better than Thomson. So what he did was this famous, what is this experiment called? Some of you might be aware of it probably from your lower classes. This experiment is basically called as your gold foil experiment of alpha ray scattering. Alpha scattering by the gold foil. This is the golden foil. These are alpha rays. What is alpha rays? What is alpha rays at the end of the day? Alpha rays are nothing but positively charged particles. They are nothing but helium, ionized nucleus. That's all. So you take out the electrons from helium. What is left is the positive charged nucleus, right? So that's at the end of the day alpha rays, or basically alpha particles. Now these alpha particles, they are made to collide on that golden foil. Imagine there is a foil made of gold and alpha particles are bombarded on it. Now what Rutherford saw, he did not expect anything, he just observed things. He saw most of the alpha particles. So most of the alpha particles, they were able to pass through the gold foil. The thin gold foil was there. Most of them, out of 100 alpha particles, maybe around 98 alpha particles were able to go to the other side without any deviation. They did not get deflected only. Then he thought, okay, atom has positive charge also, negative charge also. These alpha particles are positive charge. Positive should repel. Positive, negative should attract. But neither attraction happened nor repulsion happened. And these alpha particles, almost 97-98% of them just went as it is. So then he thought, oh, probably they didn't say hello, hi to each other. Probably these alpha particles, which are positive, did not see the other positive charges of the atom or the other negative charges of the atom close enough. They were not close enough. They went with a distance. That means the atom is mostly hollow. That means the atom is basically mostly what, my dear warriors? Hollow. Understood? They didn't say hi, hello to each other. They were very, very far. They're like, okay, that proton is there. It's okay, very far. He can't repel me. That electron is very far. He can't, attract me. So I'll just go straight. But there were very few alpha particles which went very close to the, by chance. They went very close to the positive charges of the nucleus. And once positive comes close, what happens? They will repel. Right? Positive repels. Very fast moving alpha particle comes close, it gets deflected. So it comes close, it gets basically deflected. So very few number of them, you can see over here, these red lines, faint lines, those are the few deflected alpha particles. Then he thought, they are getting deflected. That means there is some kind of positive charge which is shooing them away. See, if it was negative charge, it would have pulled it. No, it would have pulled it inside. Some alpha particles would have disappeared only. But these alpha particles got scattered a little bit. So that's how he realized that, okay, there is some kind of positiveness which is deflecting them. Then he saw very few of them almost got deflected by 180 degree. You can see most of them are going as it is. Very few of them are getting deflected, which are coming very close to the nucleus. Very few by chance. Imagine an alpha particle is headed towards the nucleus. Alpha particle is headed towards the nucleus. What will happen, my dear warriors? Nucleus is positive. Nucleus is positive. Alpha particle is positive. It will be like, hey, stop. I'm going to repel you. And it repelled back. So it went back 180 degrees. But that was by chance, by fluke, very few of them. Because most of the atom was empty. Most of the atom was empty. Very few of them came very close and they got repelled, reflected, bounced back. Right? So that made him conclude few of the things. That made him conclude few of the things, like he said, listen, atom is mostly what? Empty. Atom is, most of it is basically empty. Right? There is a, positive charge which is concentrated in the nucleus at the center. The positiveness is concentrated over there. He then also said the negative charges basically revolve. They revolve due to the electric force, acting as the centripetal force. The electric force acting like the centripetal force, and that's how it is able to revolve around that positive charge. That's what he was able to say. And he said that now Thomson, whatever he said, partially was correct. Now he was able to think, oh, the electrons are revolving, so that's why it is easy to pluck them. The protons, the positiveness is concentrated at the center, very difficult to reach the nucleus. But the electrons which are revolving, tuck, you can pluck it and it starts conducting electricity. They can be knocked out. So many effects like photoelectric effect, etc. can be explained. So this is how he was able to overcome few pointers, and he was able to say how the electron is able to revolve and it is able to overcome that electric force, and that's how it is able to remain in that orbit. He was able to explain few things, but there were still few things which even Rutherford was not able to explain. What were those things? He was not able to explain why the hydrogen spectrum, or basically atomic spectra, happens. In general, why does the atomic spectra happen? He was not able to explain why all energies or basically orbits are not possible. He was not able to explain this. Just like a satellite can revolve around the earth in any orbit, small orbit, large orbit, electrons can't do that. This orbit or that orbit, nothing in between. So there are only certain energy levels, certain orbits in which the electron can revolve, not everything. He was not able to explain that also. He was not even able to explain how is the electron which is accelerated. Why? Because it is in a circular motion. How is it not emitting electromagnetic radiation? As per Maxwell. Maxwell had told that if you take a charged particle and accelerate it, you rotate it, that's it will emit radiation, energy will be lost. So if an electron is revolving, it is radiating energy, that electron will lose energy, it will keep running. Slowly it will get tired, it will lose all its energy and it will be like, okay, I'm done. It will fall into the nucleus. That's it. The atom has collapsed. There is no longer that atom which you thought of. So, but that does not happen. He was not able to explain that also. Did you understand it? My dear warriors? Everybody clear? So then, teacher in the classroom was like, hey, Thomson, you are not able to explain. Then Rutherford came. Rutherford is like, ma'am, I know. Rutherford was able to explain few things, not able to explain few more things. So then, who came? Bohr. So Bohr is like, ma'am, I know, I have an idea. So Bohr gave some postulates, and according to those postulates, he was able to explain many more things. Again, he also had some limitations, but most of it was able to be, he was able to explain. So what are those things? Let's have a look at it. So according to Bohr's model, basically number one, he said that an electron, all right, an electron revolves in some fixed orbits, by due to the centripetal force by electric attraction of the positively charged nucleus and the negatively charged electrons. So there is some kind of centripetal force is what he said, which is only there in certain orbits, which makes the electrons revolve in basically circular orbits, in fixed circular orbits. This is very, very important. Circular orbits. He then said that the energies in these fixed or basically stationary, these are also called as stationary orbits, are basically constant. Only in these orbits the electron cannot radiate energy. If it is anywhere else, it will radiate energy. Why that happens, he did not explain, but he just said only in this orbit, this, only in certain levels or certain radius, if it rotates, it will not emit radiation. But in any other orbit, if it emits, or any other between place it is rotating, it will emit radiation. It will not be stationary. Energies won't be fixed. The electron will fall into the nucleus. That's what he said. Okay, everybody with me? Harshida, we will answer your questions later on. Okay, don't worry. First, let's concentrate on the class. It's fixed. They don't radiate energy, or basically electromagnetic radiation. He also said those orbits always have an angular momentum given by n into h divided by 2 pi. All those angular momentums which are integral multiples of h is Planck's constant, divided by 2 pi, only those orbits are allowed. Remember, angular momentum is m into v into r. So only those angular momentums are allowed who are integral multiples of integral multiples of h by 2 pi. N is basically some kind of integer. And the last thing he also said was this: if by chance the electron jumps to a higher orbit, electron can go from lower orbit to higher orbit, higher to lower orbit. Yes, it can do that, but only if it absorbs a photon or releases a photon. So if by chance there is light which is incident on it, so if there is a photon, basically light which is incident on it, whose energy is exactly the difference of the energies. If it gives exactly the energy for it to jump here, then the electron can jump from a lower orbit to a higher orbit. So a photon can be absorbed. And the electron will get excited. To a higher energy level. This is possible. Also, the reverse is possible, meaning maybe there is an electron here and it can jump to this lower orbit. This is de-excited. It has got de-excited. And in this process, it will basically, what will it do? It will emit a photon. Of the same energy as that of the energy difference between these two. If it was at 10 joules, it came to 7 joules. 10 minus 7 is 3. So 3 joules energy photon will come out. 3 joules of energy will be released. If this is at 1 joule, this is at 7 joules, So this is 1, this is 7, the difference is 6. So 6 joules photon should be entering the atom. It should get absorbed. Only then the electron will jump to a higher orbit. Is that okay? Understood? So I can say over here, the last pointer is the difference in the energy of the orbits is equal to hf, which is also hc by lambda, which is nothing but your energy of the photon, which is either emitted or absorbed. Either emitted or it is absorbed. These were the things which Bohr said. Using these postulates, using these theory pointers, he was able to explain many things. Bohr was able to explain, you know, the atomic, he was able to explain the atomic spectra. He was able to also explain the stability of an atom. Stability of an atom. He was also able to explain the, fixed energy levels. The fixed energy levels. Why energy levels are fixed and it is not in any random manner or any random value. He was able to explain all these things. He was also able to predict the radius and energies, etc. of many small atoms. He was definitely able to explain all these things. But where he failed was something called as, see, he was not able to explain why for higher atoms he was not able to derive all the formulas, why those energy formulas, the radius formulas never worked for even lithium or even carbon, oxygen. They are not very big. It failed even for these elements. He was not able to find the radius, everything accurately. So he failed for higher atoms, higher atomic number atoms. Not just that, he was not able to explain the electron cloud, orbitals, right? Suborbitals. He was not able to explain all these things. So the theory of orbitals, electron cloud, all these things he was unable to explain. Why there is a probability of finding the electron, all these things he was not able to explain. It also violated Heisenberg's principle. Heisenberg's principle was also violated. According to Heisenberg, you can never locate a particle and also tell in what direction it is moving. You can't do both the things accurately. If you know where it is, then there will be a lot of error in which direction it is going. If you know where it is going, you can't tell where it is. But Bohr's model told, oh, the electron is here and it is going with this speed. So it was violating Heisenberg's principle also. Okay, not just that, it also it was not able to explain something called as Zeeman's effect, which is basically the splitting of spectra, atomic spectra in electric and magnetic fields. You don't have to worry about it, but just remember this word, Zeeman's effect. It's basically the atom's spectrum split into some small components when you used some magnets and electric fields. So he was not able to explain that. Why does that happen? So these were some limitations of Bohr's model. These were the pluses of the Bohr's model. Till this point, is everything clear? Thomson was watermelon, Rutherford gold, Bohr was able to explain even more, right? But he failed at few things which I told over here. But most of the things for lower elements and radius calculation, atomic spectra, why it happens, all these things he was able to explain. Yep, all clear? Awesome. So based on that model, you have Bohr's calculations for hydrogen like atoms. What do I mean by hydrogen like atoms? See, In hydrogen-like atoms, there is only one electron in the orbit. Why only one electron? Because if there are two electrons, then they too will repel. I need to take into account their electronic repulsion. If there are 3, 4, 5, imagine carbon, oxygen, nitrogen, iron, zinc, all these elements, there are so many electrons. These electrons will also repel. It will be like one mess over there. So many repulsions, the electron will go in some crazy path. So that part we neglect. So hydrogen-like atoms means what? Hydrogen will do, anyways hydrogen has only one proton, one electron. Helium plus will also do. Helium plus will also do. Lithium double plus will do. Correct? Because lithium had 3 electrons. Out of that you take 2 electrons, only 1 electron will remain. For that it will work. So this is the meaning of hydrogen-like atom. This is the meaning of hydrogen-like atom. Keep this in mind. So imagine I have this positively charged nucleus. Inside the nucleus, there could be many protons. 2 protons, 3 protons, 5 protons, 1 proton, depends. So the charge of the nucleus will be basically plus Ze. What is this Z? What is this Z? It is basically the number of protons, which is also called as the atomic number of that particular element. Atomic number also of the element, right? Similarly, there will be one electron now. And this electron will be revolving around this particular nucleus in some orbit. Let's say this is the radius of the orbit, and there is electrical force on that electron like this, because of which it is accelerating towards the center, and it is performing uniform circular motion as it goes around it with some speed v. So v is the speed of the electron, r is the radius of the orbit, f is the electric attractive force between electron and the protons or the nucleus, a is the centripetal acceleration, and this particle goes in a circular orbit. That means it should be performing UCM, uniform circular motion. Okay, I hope this is clear. Yes. So Sangeeta, you will be getting the recordings as soon as you join. It should be there. Just go to the dashboard, just explore the past sessions, it will be there. Okay, I mean you can figure it out. It's just you have to explore the app, bacha. Okay, or see it from the desktop. Go through the past sessions, you will be able to see. Okay. Now, and attend the live classes, and that way you will be in touch with the syllabus, and you will be seeing me also, right, in the classes regularly. So make sure you are a part of the live classes too. Okay, so coming back over here, what you can say is this centripetal force or the electric force of attraction will be providing the acceleration towards the center. So it will be mass into centripetal acceleration. This F, I can write it as 1 by 4 pi epsilon naught, charge 1, charge 2. So it will be ZE into E upon distance between them is basically R. So R square is equal to mass into acceleration of the centripetal will be V square by R. It will be basically V square by R. You can simplify this little bit like this, ZE square. One of the R gets cancelled. 4 pi epsilon naught into R is equal to mv. That's it, mv square. That's it. So this is one equation which you can get. Everybody with me on this? Understood how we got this particular equation? The force of electrostatics will be 1 by 4 pi epsilon naught q1 q2 divided by r square, and that is mass into centripetal acceleration. Centripetal acceleration formula is v square by r. One more equation which we can use according to Bohr. One more equation. L is nh by 2 pi, L is mvr. So use the angular momentum equation. L is nothing but nh by 2 pi. L is nothing but m into v into r. So that is basically nh by 2 pi. So this becomes the second equation. If you notice, there are only two unknowns, v and r. V and r. Do you see that? V and r are the only two unknowns. Yes, we are the only two unknowns. So solving these two equations, what you get is very, very important. So first thing is radius. The radius that you get is approximately 0.529. All right. And here you have n square by z, but this is in Armstrong. Remember, 1 Armstrong is 10 to the power minus 10 meters. Main thing that you should know is r, the radius is proportional to n square by z. The radius is proportional to what? N square by z. That is what you should know, guys. If you know that, you can solve couple of problems. So keep this thing in mind. Actually, if you remember this also, it is good only. Sometimes they might ask you to calculate the radius of, the first orbit, second orbit, third orbit, hydrogen, helium, lithium, etc. So accordingly, you can substitute the value of n and z and you can find the orbit. Agree or disagree? Did you understand? Pakka? Like say for example, for hydrogen, z will be basically 1. For helium, z will be basically 2. For lithium, z will be basically 3. So depending on whether it is K shell or L shell or M shell, for K shell, the value of n will be 1. For L shell, the value of n will be 2. For M shell, the value of n will be 3. Right? So K, L, M, N, those are the names of the orbits which are given. The principal quantum number, you can put it over here and find the radius of the orbit, my dear warriors. This is the first formula. The next formula is for the velocity. All that you need to remember is velocity is directly proportional to z and inversely proportional to n. Very, very important. It is directly proportional to the atomic number and inversely proportional to n. That's all you need to know. In the books, in NCERT and in many textbooks also, you will see some crazy formula. H square is there, epsilon naught, pi is there, z is there, that is there. Don't remember all those things. That will be never asked. You open any PYQ, any NEET paper, even JEE paper, they have not asked. So don't waste your time behalting those complicated formulas. Captain Shreyas sir is telling you, just remember the proportionality. Just remember velocity proportional to z, inversely proportional to r. Radius proportional to n square, inversely proportional to z. Understood? Yes, Desri, I'll be sending you the PDF after the session is over. Now, using this, you know what you can find? Using this, you know what you can find? You can find basically kinetic energy, which is basically half mv square. You can also find potential energy, which is minus, actually it will be 1 by 4 pi epsilon naught Ze into minus E, the whole thing divided by R, and adding these two, you can find the total energy, which is kinetic energy plus potential energy. You can find all these things separately. Now, after doing all the calculations, which again is very procedural, don't have to worry so much about it for NEET. Even if you don't know the derivations, it's perfectly fine. But you should just know kinetic energy half mv square. Potential energy 1 by 4 pi epsilon naught, that is K. Q1, Q2 by R. K, Q1, Q2 by R. Remember the second charge is negative, that's why I put that minus sign. So the energy that you get comes out to be minus 13.6 Z square by N square. But the answer is not in SI units, it's in electron volt because the energies are very small. So that's why you use the smaller unit of energy, which is called as electron volt. This is what you get. Minus 13.6 Z square by N square electron volt. Number one thing, notice it is negative, just like the energy of a satellite. It is negative, just like the energy of a satellite. So this negative sign indicates that the electron is bounded or held by the nucleus. It is held by the nucleus in that particular atom. It is not free. It is not free. When energies are negative, that means you are bound. You are bound. If you are free, that means you are at infinity. When you are at infinity, guys, the energy is zero. When you are far away from everything, like I'm done. I can't take it anymore. I am going very, very far away. I went away. So when you go very far away, energy is zero, free. But when you are bounded, it is less than zero. Smaller than zero means negative number. So that's why it is negative. That's why it is negative. Is this understood why this energy is negative, guys? So when you are really, really far away, then the energy is zero. But when you are bounded, when you are held, so you are lesser than zero means negative. Keep that in mind. Now, this kinetic energy and potential energy also can be calculated. And when you actually substitute and find out, actually what you see is this kinetic energy just happens to be negative of this total energy, and this potential energy just happens to be nothing but 2 times of the total energy, meaning this will be nothing but minus of this. It will be nothing but minus of this. So basically it will be 13.6 z square by n square, and potential energy will be 2 times of this. It will be nothing but 2 times of this. So it will be basically minus 2 into 13.6 z square by n square electron volt. This is also electron volt. This is the formula. Okay, I hope this is very, very clear. I hope this is very, very clear. Potential energy, kinetic energy. Potential energy is 2 times the total energy. Kinetic energy is negative of the energy. So these things also will be helpful for you in certain problems. This is the energy. Now, if you draw the energy levels for a hydrogen atom, Z is 1, N can be 1, 2, 3, 4. So for hydrogen, basically Z will be 1. You substitute the different values. So N is equal to 1, N is equal to 2, N is equal to 3, and so on and so forth. This is the K shell, this is the L shell, this is the M shell, N shell, and so on and so forth. K, L, M, N, like that. 1, 2, 3, 4 are the principal quantum numbers. And then N tends to basically infinity. It becomes very, very large, 100, 200, 1 lakh, 10 lakh, gone. See how the energies are. For N is equal to 1, when you substitute N as 1, Z as 1, the energy that you will get is minus 13.6. The energy that you get is how much? Minus 13.6. Are you able to see it? Are you able to see it, my dear students? Just check this out. I hope this minus sign is visible. This dot is also visible. This is 13.6 with a negative sign. Electron volt. If you put N is equal to 2, Z is equal to 1, what is that you get? You get minus 3.4. Minus 3.4. Similarly, you put N is equal to 3. N is equal to 3. You get minus 1.5. Minus 1.5. And so on and so forth. You can see the value is neglecting the minus sign is reducing, but actually it is becoming less negative. This is more negative. Minus 13.6, minus 3.4, minus 1.5, minus 0.85. So actually the value is increasing. Do you understand it? It's like saying out of 4 and 2, who is more? 4 is more than 2. Out of minus 4 and minus 2, who is bigger? Opposite, no? Minus 2 is bigger than minus 4. Do you understand it? So same way, although you might see the number decreasing, actually speaking it is increasing because negativeness is decreasing. It is coming closer to 0. It's going higher and higher. So this is lower energy, higher energy, even higher, 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 higher. The values are now converging. It's not like whatever gap was here is not here. It's slightly less, less. It keeps becoming less. So when N tends to infinity, my dear warriors, the energy level will just become 0 electron volt. Okay, these are all negative numbers. Please mind it. It will come to almost 0 electron volt. So when it is 0 electron volt, this particular scenario is said to be a free state. This is said to be free energy, free electron. The electron is free. It's not bounded to anything. So this is basically the free state or the free orbit of the electron. Yep, very good. This particular state, do you know what is the name called? What is the name given to this? What is the name given to this state? This is the lowest energy state possible. This is called as the ground state. What is it called? Ground state. Ground state. This is the free state. This is ground state. Lowest energy level possible. Once it gets excited from ground, it got excited, very happy. It went to the second orbit. So can I say this is the first excited state? First excited state. Everybody with me? If it gets even excited more, then it will go to the third orbit, n is equal to 3. Can I say this is the second excited state and so on and so forth? Third excited, fourth excited, fifth excited and so on and so forth. Understood? Very good. Another thing. Imagine that there is an electron here in the ground state. There is an electron here in the ground state. I want to knock out that electron. I want to say tata, bye-bye to the electron. So the electron jumps, gets so excited it becomes free. Oh. So what will happen in this process? I think the atom will basically get ionized. It will basically get what? Ionized. So this energy and this energy, the difference is the energy which I need to give to the electron. I'll be like, hey energy, listen electron, I'm giving you this energy, jump and leave the atom. Take this money, take this energy and leave the atom. Say tata bye bye to it. It left the atom. So this energy is called as ionization energy. What is this called? Ionization energy. Is that understood? Everybody with me on this? All the things are so clear in this diagram. How negativeness decreases. How when it is free, energy becomes zero. How the gap reduces and these lines become converging and the spacing reduces. How principal quantum number can determine the energy level. What is the meaning of ground state? First excited, second excited, third excited state. What is the meaning of ionizing it and ionization energy? All these things are very clear. So my dear warriors, for hydrogen, what will be the ionization energy? Just put up the answer in the chat box. For hydrogen to be ionized, what might be the ionization energy required? Come on, think and tell me. What is the ionization energy required? Think and tell me and put it up in the chat box. I am waiting to see all your answers. For hydrogen atom, what is the ionization? Exactly. From minus 13.6, I want to take it to 0. How much do I need to give to minus 13.6? If I give plus 13.6, it will go up. If I give plus 13.6, it will go up. Yeah, that is the answer. Very good. Awesome, guys. Awesome. Proud of all of you. That is the ionization energy required. So all these formulas are very, 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 very important. Whatever I give, radius, velocity, even this thing over here, the limitations, plus minuses, how angular momentum is related. Okay, all these things are very, very important. Now, imagine this. There is one energy level. There is another level. Let's say this is N1. Let's say this is N2. If an electron gets excited, basically it gets excited and jumps to a higher orbit, that means there must be a photon which is absorbed. There must be a photon which is basically absorbed, like I told you. And from the excited state, it releases the energy, it jumps down, gets de-excited. It gets de-excited. In this scenario, it will emit a photon. It will emit a photon. It will emit a photon like this, right? These are the two scenarios possible. So, if I tell you, listen, this is N1, this is N2. N1, N2 could be anything. 1, 2, 1, 5, 2, 6, 2, 3, 2, 7, anything. 3, 4, anything. These are some energy levels. There could be more lines in between. Please understand that. There could be more lines in between, above it, really doesn't matter. These are some two energy levels. Now, if I tell you the difference of the energy between 1, 2 will be the energy of the photon, will be the difference, the energy level difference between those two orbits will be the energy of the photon. Here, I can say this is nothing but energy of 2 minus energy of 1, higher energy minus lower energy, will be energy of the photon, which is basically hc by lambda. This over here, I can use this formula minus 13.6 z square by n2 square minus 13.6 z square by n1 square is equal to hc by lambda. Solving this, I get the wavelength, which is 1 by lambda, which happens to be Rydberg's constant, which is a constant, z square 1 by basically you have n1, you will have, sorry, n2 square minus 1 by n1 square. That's all. This is what you're going to, actually, you will have n1 first, because minus minus will become plus. So n1 square minus n2 square. This is what you're going to get. This R is called as Rydberg's constant. Rydberg's constant. This constant you can get after solving this equation. You don't have to worry how to solve it. Just remember, putting all these numbers, putting value of h, c, etc. Everything when you put and neatly write it down, you will get the value of the Rydberg's constant. How much is the value of Rydberg's constant? Let's see how many of you remember it. Yes, come on. But remember this formula. 1 by lambda is r z square, 1 by n1 square minus 1 by n2 square. Come on. What is the value of the Rydberg's constant? Yes, Dana, you can watch the NEET classes as of now. I will be coming to JEE also very soon. Don't worry about it. Don't worry about it. Yes, come on, everyone. I will watch it. Nisarjan. Yup. Tickets are booked hopefully soon. 1.09 into 10 to the power what? 8, 9, 10, 7, 3, 4. Alive or not alive, guys? Yes, 7. Very good. 1.09 10 to the power 7. So this value is equal to approximately 1.09 into 10 to the power 7. So that is the answer of Rydberg's constant. Where do you use it? You use it to find what is the wavelength of light which is absorbed or emitted, the wavelength of the light which is absorbed or emitted for a particular transition. For a particular transition. That's where you use it. Now, I think it becomes very clear why only certain wavelengths can come out. Why only certain wavelengths can come out. Say for example, this is, minus 10 joules. You have this as minus 9 joules, or let's say minus 5 joules. And let's say this is minus 3 joules. So, if you make a transition from here to here, how much energy do you need to give? How much energy do you need to give? Think and tell me. From here till here, minus 10 to minus 3, you need to give it plus 7. You need to give it plus 7. If you jump from here to here, how much do you need to give it? From minus 5 to minus 3, you need to give it plus 2. If you jump from here to here, how much do you need to give? From minus 10 to minus 5, you need to give it plus 5. Exactly. You can come down also. Even if you come down, then the sign will change. That's all. If you come down instead of going up, let's say you come down like this will be minus 7. This will be minus 2. If you come down, minus 5, and so on and so forth. These are the only 3 energies possible. 7, 2 and 5. 7, 2 and 5. These are the only energies possible, because you can't go in between. You can't go in between. All the 3 possibilities are explored. So that's why the energy of the photon which will be absorbed or emitted will be either 7 or 2 or 5. So there are only fixed energies allowed. You can't have anything and everything. So that's why he was able to explain why only certain energies are released, certain energies are absorbed, why energy is not continuous, why it is discrete, why only certain values are there. He was also able to explain why the wavelengths which come out are not anything and everything. It is only certain values, because it all depends on these numbers. What can come, what can be absorbed, what can go out. Are you able to understand this? Did you understand it by this example, my dear warriors? Give me a thumbs up. Why all energies can't come out and be taken in? Why all photons can't come in and go out? Okay, only certain number of photons or certain number of wavelengths can be emitted or can be absorbed. Now, basically, because of this, if you take every element, let's say for example, some element number x, you see that okay, wavelength or photon of energy 7 is there, photon of energy 2 is there, and 7 is there, 2 is there, and 5 is there. You take some other element y or element z, it has some different energy levels. In that, you might get 1, 3, 4, okay, maybe another number like 9. You take another element z or x or y or z or whatever you want to name it. Maybe the energies of the photons which are involved here is maybe 1, 5, 9, 10 and 11. Do you see the set of numbers here are different? Do you see the set of numbers here or here or here are different? Because this is element x, this is element y, this is element z. So each element has different energies. So they have different differences of energies. Different photons will be absorbed or released. So none of their numbers entirely match. Some numbers might match, like maybe 1 and 1 here, 5 and 5 here, but the entire set of numbers is not matching for the energies of photon. So their wavelengths can't be same. That means this is like the signature. Like you have a sign, you have a sign, signature. It is very unique. So every element has its own unique set of numbers. So that's why we say that atomic spectrum, which is basically the wavelengths which are either emitted or it is absorbed, is unique to every element. Hence, it is sometimes also called as the signature. It is also called as the signature of the element. It is also called as a signature of the element because it is different for every element. Such an interesting thing, guys. Such an unique thing it is. Every element has its own sign. It will give out only certain wavelengths. Other element will give different wavelengths. So it's a signature of the element. Looking at these numbers, you can identify, oh, it is element X. Oh, it is element Y. Oh, it is lithium. Oh, it is iron. Oh, it is gold. Okay, it is carbon. So looking at these numbers, scientists can identify which element is there inside. Now, for hydrogen, when these wavelengths go in or come out, right? These wavelengths are given specific names depending on from which energy to which energy they transit. From which energy to which energy they transit, they are given certain names based on who discovered those transitions. Lyman was the guy who saw that, electrons in higher orbits, when they come down to the ground state, that is n is equal to 1, they emit a certain range of wavelengths, okay, from 2 to 1, 3 to 1, 4 to 1, 5 to 1, 6 to 1, 7 to 1. So he saw those wavelengths. That's why these lines are called as Lyman series. These transitions from any orbit, higher orbit to one first orbit, is called as Lyman transitions or Lyman series. Same way, when electrons in higher orbits come to the second orbit, 3 to 2, 4 to 2, 5 to 2, 6 to 2, 7 to 2, then those wavelengths which came out were discovered by Balmer, so it is called as Balmer series. When electrons from 4 to 3, 5 to 3, 6 to 3, 7 to 3, 8 to 3 transited, the wavelengths which came out were discovered by Paschen, hence it is called as Paschen series. The next one is called bracket series, when the transition from higher orbit happens to the fourth orbit. So from any orbit to 1, it is Lyman. Any orbit to 2, Balmer. Any orbit to 3, Paschen. Any other higher orbit to 4, it is bracket. So guys, quickly think and tell me, if an electron goes from 5th orbit to the 3rd orbit, which kind of series it is? Which kind of series it is? From 5 to 3, if it goes, which series it is? Lyman, Balmer, Paschen, bracket, P-fund. Actually, after this, there is P-fund also, but in NEET physics, till bracket also, if you know, it's good. Where is it coming? To 3, right? 3 means Paschen. So it is Paschen series. Everybody with me, right? Paschen, quickly. Very good. What happens if an electron transits from 2 to 1? 2 to 1, which series is it? Is it Lyman, Balmer, Paschen or bracket? It went from 2 to 1. 2 to 1. Which is it? It is Lyman. It is Lyman series. Very good. So now you get the hang of it. Okay. Now in Lyman series also, do you see this is the first line, second line, third line, fourth line, fifth line? How many lines will be there? Infinite, because there are infinite number of principal quantum numbers. So there will be a last line also, which will come from infinity. So there will be a last line also, which will be coming from infinity. So this will be basically n tends to infinity, and we'll be having a last line. Let me just put it over here. One line like this. This is the last line. This is also the last line. This is also the last line. This is also the last line. These are the last lines. So this one over here, this one over here is also called as the first line of Lyman. This is also called as the first line of Lyman. Similarly, over here, this particular line, this particular line that you see, this largest line, this is also called as the last line of Lyman. Understood, guys? First line of Lyman, second line, third line, fourth line, fifth line, like that. This will be the last line of Lyman. Okay, this will be also, sometimes also it is called as the limit of the Lyman series, the maximum of the Lyman series, the limit. After this you can't go. Similarly, this will be the first line of Balmer. This will be the first line of Paschen. This will be the first line of bracket. Last lines are obviously there over here. This is the last line of Paschen. This is the last line of this is the last line of Balmer. This is the last line of Paschen. This is the last line of bracket series. First, last, first, last, first, last, first, last. This is how it proceeds. Everybody able to see it? Very good. Now, out of the first line and the last line, whose wavelength will be more? Will this wavelength be more, or will this guy's transitioning wavelength be more? Think like this. Think like this, my dear warriors. Okay. Delta E of the orbits, the change in the energy of the orbits is hc by lambda. So if the energy difference is more, the wavelength is actually less. The wavelength is actually less. So strictly speaking, here the energy gap is the highest for the last line of Lyman from here to here. So when when the energy difference is more, energy of the photon is also more, frequency is also more, wavelength is less. Wavelength will be less, my dear warriors. So this will be having the smallest wavelength, smallest Lyman wavelength, smallest Lyman wavelength. Keep this in mind. Here the energy gap is the smallest, so lambda will be the highest. So this will be basically the largest Lyman wavelength, largest Lyman wavelength. Everybody with me? Understood till this point? Clear? So now quickly answer this question. Dash to dash transition will have the longest Paschen wavelength. Dash to dash transition will have the longest Paschen wavelength. From where to where? From where to where will have the longest Paschen wavelength? Think about it. Which will have the longest Paschen wavelength? Paschen series is here. Will it be the first line, second, third, fourth, or the last line, the series limit? Here the gap is more. Wavelength is less. Here the gap is the least. Gap is least means energy is less, so wavelength is more. So this will have the largest wavelength, that means from 4 to 3. From 4 to 3. Exactly. Awesome. Same way, if I tell you the smallest Balmer wavelength, is from dash to dash transition. The smallest Balmer wavelength is for which to which transition? Come on, my dear students. Yes, definitely, Rangaswamy, you can see the lectures here. Think carefully and answer the question, guys. From which to which transition will you have the smallest Balmer wavelength? This is small energy, this is large energy gap. Large energy difference means large energy of photon, small wavelength. So smallest wavelength is from infinity to 2. Infinity to 2. There you go. Awesome, guys. Very good, Priyanka, Vidisha, Subita, Subhashnini. Very good, Amita, Vedanchani. Awesome, yeah. You guys are killer. Super duper, yeah. Super duper. Very nice. So this basically tells you about all these series and how and which is going to be large, small, who is the first line, last line, maximum, minimum. All these things can be understood with this chart. Keep this in mind. The spacing is never uniform. This is the biggest spacing. This is smaller. The gap keeps on reducing as you go up. Okay, that's something which you should be aware of. Okay, all these things are done. So I think now we are good to go with problems. Are you ready for problems is the question. Are you ready for problems? Show me some fire. Show me some love by smashing the like button. If you have not yet done that yet, smash the like button in case you haven't done that. And if you have smashed the like button, indicate that by putting fire emoji over here. Let's do some problems. Ready for it? After this, the chapter is done and dusted. It will be there in your head. You will never hesitate to solve a problem from atomic structure for NEET physics. Guaranteed marks in your pocket. Here's the first question, guys. When an electron transits from 1 to 2, then the radius will become half, double, 1/4, quadruple. Half, 1/4, double, quadruple. What do you think is the answer? If it goes from the first orbit to the second orbit, acha, we need to know how is radius dependent on principal quantum number. R is proportional to n square. So if n goes from 1 to 2, that means the square of it is going from 1 square to 2 square. That means you are going from 1 to 4. So basically the radius should become how many times? 4 times, right? 4 times, right? Very good. The answer will be quadruple. Very good. D. Very good. I can see all D's for doctor. All D's for doctor in the chat box. Very good, guys. Keep it up. Awesome. Moving on to the next question on your screen. Electron goes from 1 to 2, then the speed becomes how many times? Question is slightly different. Be careful. So the speed becomes how many times? Half, double, 1/4, quadruple. Similar options, similar question, but scenario has changed. They have asked speed instead of radius. Think, my dear warriors. What will be the answer? Speed was inversely proportional to n. If you remember, z by n, inversely proportional to n. So if n changed from 1 to 2, then velocity would have changed from 2 to 1. Basically, it would have become half. It would have become half of the previous one. Half of the previous one, right? If it was n was 1, it became 12, but it is inversely related. So velocity, if it was something, it would have become exactly half of it. So hence, the answer should be half. Very nice. A for AIMS Delhi. Very good, Priyanka. Very good, Vidisha, Subhashni, Subhita, Yazni. Man, very good, Priyanka. Senthil Kumar, Siva Kumar. Very nice, Kumarji. Here comes the next question. Electron transits from 1 to 2. Energy. Oh my God, energy. Come on, think logically. Energy will become how many times? Again, you should know how is it proportional to energy. Remember, energy formulas always had n square in the denominator. N square in the denominator. So if n changed from 1 to 2, n square changed from 1 to 4. So 1 by n square would have changed from 4 to 1. So basically energy also would have changed from 4 to 1. If it was 4, it became 1. So it has become 1/4. Yes, captain is the answer. Who was that? Subhashni. Yes, captain. C for capto. That is the answer. Very, very logical statement. N became doubled. N square became 4 times. 1 by n square became 1/4 times. So energy also will become 1/4 of the previous value. If it was 4, it became 1. If it was 1, it will become 1/4. Simple. Cool? Awesome, guys. Next question. How much is the kinetic energy of the ground state electron in ionized helium? So helium ionized means Bohr-like atom, hydrogen-like atom. Okay. So kinetic energy is asked. Remember the formula for kinetic energy? It was negative of the total energy. So it will be negative of 13.6 into z square by n square. So it will be minus means plus 13.6 z square by n square. Helium means z is equal to 2. So this will be 2 square. Ground state means n is equal to 1. So this is basically 1 square. So multiply 13.6 with 4. How much are you going to get? Are you not going to get 54.4 electron volt? 13.6 into 4. Exactly. Very good. Priyanka, Vedanjani, System Hinge, Siva Kumar. Yes, Vidisha. Awesomeness. Proud of all of you. Very good. Keep it up. Moving on to the next question. But before that, remember, this was kinetic energy. A similar question could have come on potential energy. If it was potential energy, I know it is double of the total energy. Answer will be negative. That's all. Okay. So it will be double of this with a negative sign. That's all. Okay. Moving on. Next question. This is crazy question. De Broglie wavelength of an electron in the second Bohr orbit is, where R0 is the radius of the first Bohr orbit. This is crazy. Question is in the second orbit, what is the de Broglie wavelength? Okay, what is the de Broglie wavelength? De Broglie wavelength of any particle is h by p, right? It's h by p. Basically, it is h by mv. Okay. I do one small thing. H by, instead of mv, why not write it as mvr? Then r will also come on the top. Is that right? Now, why did I do it like that? Because I know what is this. This is nothing but angular momentum. mvr is angular momentum. Okay. So, what is angular momentum, my dear students? It is nothing but n into h divided by 2 pi. N into h divided by 2 pi. H cancels. So what do I get? I get 2 pi goes on the top, r divided by n, right? 2 pi r divided by n, right? But what is this r? R is the radius of that orbit. Radius of whatever that nth orbit is. I know one more thing. Lambda will be equal to 2 pi by n. Any radius, I have given you that formula, guys. It is 0.529 times n square. Whatever radius you have of the nth orbit is 0.529. What is 0.529? It is the radius of the first orbit. Basically, it is r naught into n square. Correct? Yes or no? It is r naught into n square. This is the formula, right? That r naught actually is 0.529 Armstrong. Oh, so instead of r, why not put r naught into n square? So see guys what will happen. N will get cancelled. So I'll be left with 2 pi r naught into n. 2 pi r naught into n. Everybody with me? 2 pi r naught into basically n. So guys, what is the orbit number given over here? Think over here. What should be the orbit number? The orbit number is second, right? So what is the value of n that you are going to use? You are going to use 2, right? So 2 into 2 pi r naught, what will it be? Come on. Yes, come on my dear warriors. What will it be? It will be option C. Very good. Hence it will become 4 pi r naught. That is the answer. 4 pi r naught. That's it. Great. Awesome. Okay. So let's go on to the next one. I think the answer marked here is wrong. Ignore that. The answer is 4 pi r naught. Next question. In the following atoms and molecules for the transition from 2 to 1, the spectral line of minimum wavelength will be. Oh, from 2 to 1 you are transitioning. The spectral line of minimum wavelength will be by hydrogen, deuterium, unionized helium, ionized lithium. Not unionized, unionized. Unionized means single ionized. Okay. Hydrogen, deuterium. What is the difference between hydrogen and deuterium? It's an isotope. Hydrogen has no neutron, only single proton, single electron. Deuterium, one proton, one neutron in the nucleus and one electron revolving. Neutron has no charge, so electrically there are no differences. Chemically, no property differences. It's only an isotope of hydrogen. That's all. So guys, there is a formula which I just gave you. 1 by lambda is equal to r z square 1 by n1 square minus 1 by n2 square. Here n1 and n2 is clearly fixed. This is 1, this is 2. The only thing in my control is z. What do I want? I want minimum wavelength. That means this wavelength should be small. That means this ratio should be very, very large. That means z square should be large. How do you make z square large? Whose z is the highest? Hydrogen, z is 1. Deuterium, z is 1. Helium, z is 2. Here, z is 3. So this is the largest of the all. So hence the answer is D. Diionized lithium, guys. No, it is not hydrogen. Many of you made a mistake. You forgot it is 1 by lambda. You made a mistake, guys. It was 1 by lambda. Thank you, Jessica. Thank you so much for all the love from Andhra. Thank you so much. Chala istandi. Okay. Thank you so much. Okay. So, as per Bohr's model, the minimum energy in electron volt to remove an electron from the ground state of doubly ionized lithium is how much? As per Bohr's model, to ionize it, lithium, what will be the ionization energy? Come on, think about it. ionization energy will be the negative of the total energy, as simple as that. Whatever energy is there, like for hydrogen, it was plus 13.6. So just, it is the negative of the total energy. So it will be 13.6 into z square by n square. N is 1. What is z? What is z? Z is basically 3. So basically this is 3 square. Come on, what is the answer? What is the answer? 13.6 into 9. Just do it. It will be close to 122.4. This is the only largest number. Come on. 13.6 into, this will be 9. See, 13 tens are 130. So 13 nines are will be less than 130. But because it is 13.6, it will be closer to 130. So the only option possible is 122.4. Think logically, no? Because 13 nines are nothing but 117. So it has to be more than 117, but it has to be less than 130 also. Because 13 tens are 130, 13 nines are 117. Understood? So the only option is 122.4. Don't sit and calculate in case you are thinking of calculating it. Look at the options, eliminate it. That's all. This is the next question. Ionization energy of the electron in the hydrogen atom in its ground state is this much. Atoms go to a higher energy level to emit 6 wavelengths. What is the highest energy level? This is crazy. It emits 6 wavelengths when it gets excited. Okay. So what is that highest energy? See, I'll tell you in a very simple way. This is n is equal to 1. This is n is equal to 2. If this is the case, it will only emit 1 wavelength. Okay. Let's say there are 3 levels. Let's say there are 3 levels. Then this is possible, this is possible, even this is possible. These are the 3 possibilities. Okay. When you have 1, 2 and 3. Similarly, think 1, 2, 3, 4. 4 energy levels are there. 1, 2, 3, 4. Then what will happen? This is possible, 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 this is possible. These are the only possibilities. So here there was only 1 possibility. Here there were 3 possibilities. Here there were 6 possibilities. In general, if you notice, this is the highest energy level. 2, 3, 4. These are the highest energy levels. These are basically the number of, these are the number of wavelengths. The number of wavelengths that will come. The number of wavelengths that will come. In general, if you see, no, what the formula is, the number of wavelengths, the number of wavelengths that will come is always this number, whatever that number 4 is there, n, into n minus 1 by 2. Try it out. 2 into 2 minus 1. What is 2 minus 1? 2 minus 1 is 1 by 2. So 2 into 1 by 2 is 1. Yes. Here put n is equal to 3. 3 into 3 minus 1 by 2. 3 minus 1 is 2. 2 cancels, you will get 3. Yes. Here put n is equal to 4. 4 into 4 minus 1 by 2. 4 into 3 by 2. 4 3s are 12. 12 by 2 is 6. Yes, you get it. So this is a general formula. If you remember it, it will be very good. Oh, so according to this problem, 6 wavelengths are there. So the highest energy will be basically n is equal to 4. So B for Bombay, B for banana. That is the correct answer. How many of you wrote B? Dr. King, yes. BK wrote B. Yes, Subhashini, the answer is B. So keep this formula in mind, guys. Okay, very, very important formula which will save your day. I explained you how it comes. Okay, you can see the trend over here. Even if you don't know the permutation combination part, it's okay. But remember, this is true for everything. You can use it for n is equal to 5, 6, 7, 8 also. That is the formula. Okay, moving on to the next one. Electron is in its third excited state. Okay. The maximum wavelength will be emitted for which to which transition? The maximum wavelength will be emitted for which to which transition? It's in its third excited state, guys. Think about it. It's in its third excited state means actually which energy level? Actually which energy level? third excited state. Third excited state. This is ground. That means n is equal to 1. Then this is first excited state. Then this is second excited state. This is third excited state because this is ground. This is first excited. This is second excited. This is third excited state. Okay, so maximum wavelength will be from which to which transition? 4 to 3, 3 to 2, 2 to 1. What do you think? I mean, these lines are actually not even equally spaced. Remember it? Here by mistake I showed it equally spaced. Technically, if this is here, and next is here, next is here. That is how it is. So if you want maximum wavelength, that means the energy gap should be minimum. Energy gap should be minimum. The smallest gap is right over here. The smallest gap is right over here. This is the smallest difference of the energies that you can get. So from 4 to 3 should be the answer. From 4 to 3 should be the answer. Yes, it is. So answer is 4 to 3. No, it is not B, it is A. Yeah. I hope this is clear. Govind, I don't need to join anywhere for popularity. My main aim is to teach students. Okay? Popularity will come if a teacher is good. If you have the right intentions, I feel no matter where you are, you will be popular, you will be known. And if you do genuine work, if you are actually, helping the students, you will definitely, achieve success and become popular. That's my mantra. That's what I believe in. And for all the students who are in English medium, be it from abroad, there are so many students who watch our lectures from abroad, like UAE, Muscat, Doha, even Singapore, some people from US, and Sri Lanka, Nepal, Bhutan, right? They also get benefited. Obviously, many students from Northeast get benefited. Many students from, many cities across the country, and especially many students from South India also get benefited. So guys, this channel is for everyone. Let me remind you of that. Okay. And once the intentions are very, very clear, I'm pretty sure, everything will go well. That's what I feel. Okay. So next, we have reached the end of the session. This is a homework question, which is going to come up on your screen. This is your homework question. Just try to do it. Hint is use this formula. 1 by lambda is r z square. 1 by n1 square minus 1 by n2 square. Just use this. Okay. 2 times. That's all. In the first case, it is from third orbit to second orbit. So put n is equal to 2 here. Then put 3 here. And in the next case, when it jumps from fourth orbit to third orbit, so put 4 over here and 3 over here. That's it. Solve this 2 times. Okay. First time the wavelength was lambda. What is the wavelength next time? Lambda prime is how much? That is the question. Okay. So solve it, guys. It is very simple. Just use this formula. This is the hint which I have given. I want everybody to post the answers in the comment section. Okay. Post the answers in the comment section. So I hope you have learnt a lot from today's lecture, especially the problem solving would have been very useful for all of you. How to use those formulas and applications of those formulas. Remember, more than derivations, remember those basic formulas which are given you for radius, velocities, energies, ionization energy. Understand the terminologies. Go through the NCERT, just see the pluses and the minuses of each theory, be it Thomson's, be it Rutherford, or be it Bohr. Okay, what were the advantages, disadvantages of each theory? That's all. That is the main thing of this chapter and the atomic spectra. If you do this, guarantee you will get marks in NEET physics. Okay, so ready for the next class of nucleus? Nucleus class coming on Monday. Nucleus class is coming on Monday, guys. Get ready for the nucleus class. We will be completing whatever is there in the NEET syllabus on Monday. I'll be seeing you then. Stay tuned on the channel, and I want everybody to go on the nucleus lecture whenever it is live. Smash the like button, mark your attendance, and leave a comment after today's class. Day 2 of modern physics done. Day 2 done. Let me know in the comments once you have watched the lecture, be it live or recorded. Bye bye, guys. Take care. Senthil Kumar, Vedanchani, Kauri, Priyanka, Swashni. Take care. Siva Kumar. Bye bye, DK. Bye bye, man. Bye bye, Rupasri. Bye bye, everyone. Senthil Kumar. Glad you guys made it till the end. Take care. Hasta la vista. Captain Shreyas signing off.